So let's see permutation. So what does permutation means? Permutation means arrangement. So suppose you have n places and you have n objects. So you have to arrange n objects in n places. So how many ways you will be having? So like let's derive it one by one. Suppose take example, suppose you have 5 places and you have 5 objects. All are distinct objects, like not similar, all are distinct from one another. So let's try to fill the first place. So here, suppose if you want to fill this, so you will be having 5 objects to fill this. So now suppose 5 objects, so 5 ways you have to fill this. So once this object is filled over here, suppose O1 has come here, so now you are left with only 4 objects and 4 places. Now suppose you want to fill this place, so you have 4 objects, so you can fill it in 4 ways. So suppose here also like one object is filled, so now we are left with 3 objects and 3 places. So if you want to suppose fill this place, we are randomly selecting any place, because in arrangement like it should be random. So now here you have 3 objects, so you can fill it in 3 ways. So suppose this object is also filled in this place. Now you have 2 places and 2 objects. So suppose here you have put the object, so you had 2 ways to do so, because you are left with only 2 objects. Now final object you are left with, so you will have to put it here only, and for that you have only 1 way. So now if you see that you have total how many ways of doing this work, it is 5 factorial. So now let's extend this, because we have seen for 5 places we have and 5 distinct objects, our total number of ways of arranging it was 5 factorial. So similarly, if there are n places and n distinct objects are there, so you will get total n factorial ways of arranging them. So now let's see a special case of permutation where 2 or more like objects are of similar nature. For example, let's see A, B and C. So how many ways you can like arrange these 3 objects in 3 places? So it will be 3 factorial ways or 6 ways. Okay, so now let's see what are the 3 ways. A, once like flip this, C, B, then if suppose let's fix B at first place, then A, C and B, C, A, and if you place C here, then A, B and B, A. So you can see the different ways in which these A, B and C, 3 distinct objects can be placed in 3 places. So what happens if like B is replaced by A? Suppose you have like 2 of them are similar, like A in place of B is also A. So now replace the B's with A's in this. So what will happen? So A, C, A, then again A, C, then A, C, A, then C, A, then in place of B again A, then C, A, A. So what you can see is that here these 2 are similar, similarly these 2 are similar, and again these 2 are similar, like AAC and here also AAC. So here what you get is that like we get only 3 ways in the second case. So what we can say is when 2 are similar, so this formula like changes to 3 factorial by 2 factorial, because 2 are of similar case, like 3 are 3 objects in numerator, so 3 factorial, and if 2 are similar then total 2 factorial in denominator. So let's generalize this special case. So if suppose n objects are there and n places are to be filled, and like you have to arrange n objects into n places, and suppose P of them are alike, similarly Q of them are alike, and suppose R of them are of one type like alike. So now how many ways of arranging them? So our formula will become n factorial by P factorial, Q factorial and R factorial. Like in last also we saw that 3 factorial by 2 factorial. Similarly, like we can generalize it in this way. So if n objects are there and it has to be arranged, like we are studying about arrangement, that permutation. So the permutation formula will change in case if you have like out of n objects, the p out of one type, q out of one type, and r of one type, this formula will become. So let's see some example. Like let's take one example. Suppose apple. So you can see 5 words are there, and suppose you have 5 places, 1 2 3 4 5. So how many different like arrangements will be possible? So if you know the formula that it is n factorial, so n is here 5, so 5 factorial, but you have to divide here by 2 factorial. Why? Because there you have 2 p, so 2 are alike, so it is divided by 2. So similarly, if you take one more question, suppose one question is banana. So suppose you have these 6 objects and you have to like arrange them in 6 places. So how many total number of arrangements are possible? So here what you will do is you will count the number of objects 1 2 3 4 5 6. So 6 factorial, and in denominator how much you will put? Like a 1 2 and 3 a's, so 3 factorial, and n also, so n you are having 2 n's, so 2 factorial. So these are the total number of ways of arranging banana word. So I hope you have understood this. So now let's see a case where we see application of both permutation and combination. So for example, you have 5 places, but you have 8 objects and all are distinct objects. Okay, so now how you will fill these 5 places with 8 objects and total number of ways, if suppose you are asked with this, so how you will like further go on with this? So what you can do is here you can first select 5 objects from here. So step 1, you can select 5 objects. So how you can do so? By combination. So how many ways will be there? 8c5. So step 2, what you can do is now you can arrange the 5 selected objects, 5 objects all which are distinct in 5 places, because you have 5 places. So you can do it by permutation. So 5 p5. So now these 2 steps, like you have to do both the steps, like step 1 and step 2. So you know that whenever we have and, like both work has to be done. So in that case you will get a multiplication. So here you get 8c5 and here you get 5p5 is 5 factorial. So these, so whenever suppose you have 9 places and suppose 4 distinct objects. So how you will, what is the number of ways of arranging these 4 objects in 9 distinct places? So in that case what you should do is first you should select 4 objects out of 9. I have written a reverse. So suppose like 4 places are there and 9 objects are there. So in that case you have to first select 4 objects out of the 9 objects and then arrange those 4 objects. So these number of ways. So I hope I have cleared this concept.